Okay, this is the pretest for Unit 6. Deals with exponential equations and therefore logarithms. And this last set of 5 questions is all about logarithms. And so, firstly, you need to understand the notation, or need to remember the notation. The ln, this is an ln, refers to natural log. And all it is a syntax issue, right? The syntax is referring to log base e, right? And e, of course, is Euler's constant. It's transcendental. It's a number about like pi. Um, it's defined in terms of a sequence, and so from there, just don't be concerned. It's exactly the same situation. There isn't anything special about it, uh, except for this transcendental number e. It follows the exact same log laws as any base would follow. The log of a product is the sum of the logs. The log of the quotient is the difference of the logs, and the log raised to a power is the power times that log. And so we're going to use these exact same concepts. Don't let the ln notation scare you in any way. It's going to follow all the same exact laws. So with this exercise 6, you have natural log of x equals 10. Well, all I'm saying is all that says is that the log of x base e, again, about 2 and 7/10, Euler's constant, equals 10. Okay? So, thinking in terms of our log rules as an overarching idea, that a log is an exponent. Right? If you use that idea, you can keep yourself out of trouble sometimes. Is as in equal sign, right? A log is an exponent. So this 10 is an exponent. All right? That 10 is representing an exponent of some base, right? It's an exponent of some base. Well, the base is the E. The base is the Euler's constant. There's an E that's understood to be here. People don't write it, right? It's referred to by this syntax. Ln means log base E, okay? And it is an exponent. So what does x equal? Well, if we just convert it to exponential form, what this is saying is that e to the 10th power is x. And so that's all we were expecting you to put in the answer space there. X is e to the 10th power. Okay. Another way to look at that, maybe check that, right? Take that answer and put the e to the 10 right in here. And we're going to show that that equals 10. Well, how? Well, we're going to use this exponent law right here. When you raise a power to a power, right? And so that lets us write this as this. And we mentioned in the previous video, log n base n is always what, right? I didn't put it back on this screen, but log n base n is equal to what number? Well, of course, that's a 1. So this expression right here, that's a 1. And 10 times 1 equals 10. And so that checks. So the answer to exercise number 6 is e to the 10th power. You can just leave it like that. Now, get rid of this stuff and move on to Question 7. We have 8 times e to the 2x equals 20. All right. So from there, first of all, important to understand that 2x is only on the base e. The 2x is not on the 8. That 8 is multiplied right there. And that 2x is not being applied to that 8. So step 1, I'm going to do this division. Undo the multiplication of the 8 by dividing by 8. Now, if you want to do that division, you can. You get e to the 2x equals 2 and 5 tenths. Right? 20 divided by 8, 2 and 5 tenths. If you want to write it that way, you don't have to. Or if you want to reduce it, you could. Whatever. Now, back to a variable exponent, just like we were in the questions 1 through 5. Okay? So to solve this, I'm going to do a log to both sides. But instead of doing a log base 10, you could. Wouldn't be wrong, right? Instead of doing log base 10, it's going to be a little bit handier if instead of doing log base 10, I do log base e, right? Now, instead of writing it log base e like that, we use this syntax ln, which means log base e. Okay, and of course we apply it to both sides. Now we use the exact same exponent law. This thing can now be multiplied, and what is the natural log? Don't let it bother you. What is, just so you can see what's going on here, get through the syntax, right here, what's the log base e of e? Well, clearly that's a 1. So it's just, in a lot of cases, for a lot of students, what we see is the syntax knows that. So the natural log of e, that's the number 1. And it's based on this idea right here. It's based on log n base n always being 1 for n greater than 0. Okay? So now with 2x equal to the natural log of 2 and 5 tenths, all we have to do is take our multiplied 2 and divide by it. And we got natural log 2.5, 2 and 5 tenths divided by 2. There's the answer you put in your answer space using the math pad. Okay, so that's question number 7, and we'll move ahead to question number 8, and this one should go fairly quickly. You've got e to the 3 minus 5x variable exponent equals 16. Okay. Again, since it's base e, I'm going to use the natural log on both sides. This exponent can now be rewritten as a multiplication problem because we went to the log realm. That is a quantity. You want to remember that. And there's your natural log of e again. What's going to happen to that? That, of course, is going to be a 1. So we have 3 minus 5x equals natural log 16. I'll bring the 3 over, get negative 5x equals natural log 16 minus the 3. And then this multiplied negative 5, just as you do in elementary algebra, you remove that multiplied negative 5 by dividing. Now, there are a variety of other answers, other ways you could write that. That isn't maybe as pretty as some people would make it. We can do the division by the negative, right? Could be rewritten as, in other words, factoring a negative out of all these terms. This would be equivalent to a positive 3, a negative natural log of 16, divided by a 5. And again, the way you get to that is you factor out a negative from all the terms and cancel the negatives. So there's question number 8. All right? And hopefully now you're remembering your exponent rules and log rules from the high school experience and feeling a little better about this. Um, Now, if we move ahead to question number 9, and I'll do that by just sliding up the page a little bit, you're looking at 52 divided by 1 plus e to the negative x. So it's an exponential equation because we have a variable exponent equals 4. Well, here's a hint. Think of it as a proportion. And if it was a proportion, how do you solve your proportions? And so you get 52 equals 4 plus 4e to the minus x. Everybody good with that by cross multiply? And now, pretty apparent, going to bring the 4 over. You get 48 equals 4 e to the minus x. Understand that this multiplied 4 doesn't have anything to do with that negative x. So very easy. We just divide both sides by 4. And we get e to the negative x equals 12. Okay. And now that we've got the term with the variable exponent on it isolated, we're going to do a natural log to both sides. We could use any base log we want, but because this is a base e over here, it's going to save us if we use the natural log. Okay. And now we employ this log law right here. This is the one that gets used over and over and over again. And we get the natural log of 12 equals negative x times natural log of e. And the natural log of e, one more time, all that means is this. And of course, that's a 1. So we've got a natural log of 12 equals negative x. And now if we remove the negative sign, pretty apparent that your answer is going to be negative natural log of 12 equals x. There's what you put in the answer space. All right. So that's question number 9. And we'll move ahead now and get our last question from this pretest. And it is hopefully going to be very easy for you at this point. We've got 3 natural log of x minus 4 equals 6. So I'm going to emphasize this one more time. I want you to understand the syntax and not have it be a bother for you. So what that says is this: 3 log base e of x minus 4 equals 6. That's what that's meaning. This multiplied 3, I'm going to divide that out. moving towards getting the x, determining x, just as you would in any algebra situation. And of course, 6 divided by 3 is a 2. Okay? Now, the idea you need to use is that a log is, as in equal sign, an exponent. And I'm just saying that to remind you that this 2 right here, that 2, that's an exponent. That's a power. Okay? That's a power. What is it a power of? What's the base? Right? Well, the base is that e right there. And that is x minus 4. Now, the e squared, we just leave that like that. Just leave that like that. No problem. It's about 2 and 7/10 squared, so it's a little bit less than 9. Bring the 4 to the other side by adding it, additive inverse, and you get e squared plus 4. Right. Now, the way that ends up looking in terms of our syntax here is the way you're going to see that written in most textbooks. It's going to show up like that. And then their next line is going to say x minus 4 equals e squared. And it's that step right there that students are always coming to us about in help sessions and office hours, that sort of thing. And they're mystified right there. Okay? Don't let the syntax bother you. Okay? It's a special uniform it gets to wear because the constant E, Euler's constant, is so special. Bring the 4 over by the additive inverse, and you got E squared plus 4. That number, right? A little bit less than 13, right? Because E is about 2 and 7/10. When you square a number a little bit less than 3, you're going to get something a little bit smaller than 9. And if you take a number a little smaller than 9 and add 4, you're going to get something a little smaller than 13. The answer we want in the answer space, e squared plus 4. Okay, so that's the pretest for Unit 6. We uh, we hope if you have any questions or problems or want some other things reviewed or see more of a certain kind of exercise, you'll let us know, and we'll try to produce something for you that can help you with these exponential equations and working with the base e, um, to alleviate any difficulties before you get to campus.